Alright, good morning everybody. Today we are going to be talking about a couple more of our transformations. First one we're going to cover is rotations. So the sheet that I have in front of me, you guys all have in your note packet. So I want you to find it. It's the bottom portion of one of the notes. So you should find that and be getting it out right now. Okay, so before we get into the major part of the notes, I want to remind you something about a coordinate plane. So if we have our coordinate plane here, and I start a point here and I go all the way up to this line here, that is 90 degrees. When I go from this point back down to this straight line, you guys know that's 180. As I go back down to the bottom, 180 plus another 90 makes 270. And then a full circle, 360 degrees. Okay? So now that we've gotten that out of the way, we can get into the notes. So these are rotations. First thing I want to say is that rotations are always counterclockwise, meaning in this first example, when it says we're going to rotate this S 90 degrees about the origin, that's the center, it's going to go 90 degrees in this direction, so meaning it's going to end up somewhere here in quadrant 2. Okay? Now that I've discussed how they go counterclockwise, I don't want you to stress out too much about the word counterclockwise. Okay? I just want you to focus on the directions that I'm going to give for these notes. So, the first step you're always going to do, no matter what, is going to be to find your original point. So point S, we go over 2 to the right and up 3. So our point S is going to be 2, 3. Alright, here's the important part. This is how you're always going to be able to find the correct rotated point no matter what. Okay? You are going to pick up your paper, turn it to the right 90 degrees, because that's what this problem is asking for, a rotation of 90 degrees. Pick it up to the right 90 degrees. Then we are going to treat this line like a y-axis, and we're going to treat this line like the x-axis, just like we normally would. Then I want you to graph your point S on these new axes. So you're going to go over 2, 1, 2, up 3, 1, 2, 3. There's my new point. Once we have the point on our paper, we're going to turn it right side up again. And we're going to figure out what those coordinates are. Okay? We're going to figure out what the coordinates are. We go to the left 3 and up 2. So that is -3, 2. And that's it. That's all you have to do. Pick up your paper and rotate it to the right. So because I don't want you guys to forget that we're rotating it to the right, I want you to write on your notes right now that you always turn paper to the right. Alright, we're always turning our paper to the right. So now we're going to go to example number 2. It says that we rotate T 180 degrees about the origin. So first step, same as always, we're going to find our point T. So we go, start at the origin, go to the left 1 and down 2. So that's going to be -1, -2. Alright, so the first time we rotated 90 degrees, so we turned it once. This time it's 180 degrees, so we're going to turn it twice. There's 1 and 2. So our paper should be upside down. Okay? Now we are going to graph the point -1, -2. -1, -2. This is where your point should be. So I'm going to turn the paper right way around again. And then I'm going to find those points. and it is at 1, 2. This is my point, T prime. And this over here is my point, S prime. So T prime is at 1, 2, and that's all it takes. Moving on to example 3. This one wants us to rotate 270 degrees. So first, this says R. On our picture it says S, so I want you to really quick on your picture, change this to an R. Okay? Then we're going to find our original point, R. It is at 1, 2, 3, negative 1. Okay? Rotate 270, so that's 3. 1, 2, 3. So we're going 1, 2, 3. Always to the right. So it was at 3, negative 1. We're going to go 1, 2, 3, negative 1. That's my point. Turn it back right side up. Label it R prime. And then we're going to find those coordinates. Negative 1, negative 3. Alright, so that's all it takes. Those are the only rotations you're ever going to see. 90 degrees, 180 degrees, and 270 degrees. Okay? Always turn your paper to the right. Okay, so now if we go and we try to rotate this whole triangle 90 degrees, we're going to do the same exact steps. We're going to find our original point A, our original point B, and our original point C. So let's find those real quick. A is at 1, 2, 3, 4, negative 4, positive 4, negative 4, positive 4. B is at negative 4, 1. And C is at negative 1, 1. Alright, we are rotating 90 degrees. And we are graphing those points. So that is negative 4, 1, 2, 3, 4, positive 4, 1, 2, 3, 4. So this first point is our A prime. Next is B, negative 4, 1. Here's our B. And C, negative 1, 1. Flip this back right side around. I'm going to label my points. A prime, B prime, C prime. I'm just going to go ahead and make my triangle. Okay. And that's it. That's all you have to do. So now we just have to find those points. A prime is at negative 1, 2, 3, 4, negative 1, 2, 3, 4. B prime is at negative 1, negative 4. And C prime is at negative 1, negative 1. That's it. An easy way that you can tell that you've done it correctly is to look at your shape and look at how it looks. So here's my triangle. I'm going to shade that in green a little bit so you guys can see it really well. Alright, so we have a horizontal side here, vertical side here, and then my hypotenuse. When I turn my paper 90 degrees, my shape should look exactly the same as it does there. So when I turn my paper 90 degrees, does it look exactly the same? We have a horizontal side, a vertical side here, and then my hypotenuse over here. So yes, so we did it correctly. Alright, these are all the notes we have for rotations. So if you missed anything, you guys can rewind it or pause it and spend some time to finish this up, and then we're going to go on to dilations next.